Welcome to this explainer. Let's kick things off by setting the scene a little bit. Picture this. You're staring at a dark-themed database console. There's a cursor just endlessly spinning on your screen, and sitting right there in your queue is an urgent, completely panicked user ticket. A critical page on your application is hanging, users are getting frustrated, and well, you need answers, and you need them right now. This is a real-world pain point we see all the time in IT support. Why on earth is this transaction history page taking 8 whole seconds to load? Now, 8 seconds might not sound like a big deal if you're, say, waiting for an elevator, right? But in database terms, that is an absolute eternity. Load times like this instantly trigger urgent support tickets. The application basically feels broken, the user is entirely locked out of their data, and suddenly everyone is looking directly at you to figure out why the database is choking. But here is the really good news. You actually don't need to immediately escalate this to a senior database administrator to find the bottleneck. You have the ultimate detective tool right at your fingertips, and it's called Explain. Explain is literally your window into the database engine's decision-making process. It tells you exactly what strategy MySQL is planning to use to grab your data. So let's jump right into reading the Explain output and zeroing in on those key columns. To get this raw tabular output, all we do is simply type the word explain right in front of our slow select statement. And yeah, at first glance, it looks pretty intimidating, doesn't it? You've got all these columns like ID, select type, table, partitions, possible keys, and it just keeps going. But as a first responder, do not let this massive wall of data overwhelm you. Out of that entire spread of headers, you really only need to focus on 4 critical columns. First up is type. This is the access type. And frankly, it is the absolute most important column for diagnosing performance issues. It tells us exactly how MySQL is finding the rows. Second is key, which tells you the specific index MySQL actually decided to use. Third is rows, meaning the estimated number of records it has to examine. And finally, extra, which gives us crucial context, like warning us if the database is doing super expensive extra work, like a file sort. Now, we need to talk about the danger of table scans, which is basically what happens when MySQL decides to read absolutely everything. To understand what we're looking for in those columns, we have to look at the absolute worst-case scenario, the full table scan. If you look at your explain output and that type column says all in capital letters, major warning bells should be ringing in your head. It means MySQL couldn't find a suitable index anywhere, so it just threw its hands up and decided to read every single row in the entire table to find your data. Let's just pause and visualize that for a second. Scanning a table with 10 rows, totally fine. But scanning 100,000 or maybe a million rows sequentially every single time a user clicks on transaction history, that is computationally exhausting. It's going to eat up your CPU, it's going to thrash your disk I/O, and it will completely bottleneck the entire system. In modern high-scale environments, this is hands down the #1 cause of database-induced latency.
So, how do we fix it? We fix scans with indexes by basically giving MySQL a table of contents.
If a full table scan is like reading a massive textbook page by page just to find one specific paragraph, an index is the book's table of contents. Just look at the dramatic difference an index makes here. Before the index, our access type is all. We're scanning 100,000 rows, and users are stuck waiting 8 agonizing seconds. But after we add the index, the type changes to ref, the rows scan drop to just 10, and the execution time completely plummets to just 1 millisecond. We fix the issue simply because that key column is no longer null. MySQL is actually using our table of contents. And this brings us nicely to using the Visual Explain tab, which is MySQL Workbench's incredibly helpful graphical view. You know, staring at text tables is fine, but for complex queries, you really want a broader perspective. What's absolutely fantastic about Visual Explain is that it color codes the operations for you. You don't even have to read the text. A terrifying red node instantly means you've got an expensive all scan. Yellow means range, which is usually okay. But what you really want to see are those comforting green or blue nodes. Those indicate highly efficient index lookups. Reading this flowchart is actually really simple once you get the hang of the mechanics. You just follow the logic from the bottom to the top and then from left to right. As you follow the path, just check the color of the access type node and take a quick glance at the estimated rows. It completely takes the guesswork out of complex joins and nasty nested queries. Okay, let's tie this all together with a real scenario. Let's revisit that transaction history page and our stressful 8-second ticket. We take our slow 8-second query and we run it through explain on a local instance loaded up with 100,000 sample rows. Instantly, we spot the red flag. Look at the transactions table. The access type is all, the key is null, and it is scanning all 100,000 rows. Why? Because there's no index supporting our filters on user ID and timestamp. The diagnosis here is incredibly clear. We're missing a composite index. So we write our fix. Create index IDX underscore user underscore time on transactions, passing in user ID and timestamp. We deploy this, we rerun our visual explain, and we literally watch that giant, terrifying red node instantly transform into a beautiful, efficient blue lookup node. Just like that, the database is breathing easily again. This methodology completely transforms the entire lifecycle of an IT ticket. Minutes after the user complains, an empowered support engineer runs explain. Within hours, they've identified that missing user underscore ID and timestamp index. Instead of this dragging out for days or weeks, escalating to a DBA, the fix is deployed, the load drops to milliseconds, and the ticket is successfully closed way ahead of the usual agonizing curve. I really want you to remember this crucial takeaway. The database isn't a black box. It just needs to be asked the right questions. Explain empowers you to ask those exact questions calmly, clearly, and efficiently without needing to hit the panic button and escalate every single slow query you see. So I'll leave you with this thought to mull over. What hidden bottlenecks are you going to uncover in your very next slow query ticket using Explain? The next time a page hangs, don't just guess what's wrong. Open up MySQL Workbench, drop Explain in front of that query, and see exactly what the database is trying to tell you. Give it a try on your own slow query logs today and take back control of your application's performance.